Assalamualaikum warahmatullahi wabarakatuh. Hi again. Continuing from the previous video, we are now trying to find the air consumption rate of intensifier in standard cubic feet per minute. This is our system as we have looked before. So we have the pneumatic part and the hydraulic part. So the diameters of the pistons are shown here. I've labeled them. In the last video, we have computed all these parameters. Okay, volume displacement of the oil intensifier oil piston. So how much volume is displaced every second. How much, okay, this is how far the hydraulic cylinder is moving. Volume displacement of the blank end of intensifier air piston. So how much volume is displaced is 101, and then the flow rate, which is the volume divided by the second. So this is oil, so we just use oil divided by the second. In part F, we need to find the air consumption rate, which means how much air is consumed is taken from the atmosphere into the system. So there will be a compressor transferring the air from the atmosphere to our system. So how do we do that? So basically, we have the air taken from the atmosphere. Let's just label this as P1, and then there's the air in our system. Let's just call it P2. And of course, we know that the air will be taken with a certain volume every second from the atmosphere. So we can say certain volume V1 from the atmosphere, and P2 the volume of air used in the system, which is the 101 cubic inch here. So we need to find V1, okay, because we know if we can find V1, then we can just find the flow rate, which is Q is just V over T. However, what would be the P1 we know, but what would be the pressure of air here? V2 is given. We have found V2 before. So 101. But what would be the pressure of air here? So can we find it? Of course we can. We can just using this information that we have on the load, we can find the oil pressure, and then we can find the force applied to this piston, which is connected air and oil piston. Then we can calculate the pressure. Remember also that this P1 V1 and P2 V2, if you recall the ideal gas law, it is related. If you recall the ideal gas law, it says that P1 V1 over T1 is equals to P2 V2 over T2. If we have pressure, volume, and temperature at a certain condition, it should be equal if we change some parameters. In our case, we can say this is T1 and T2 we can remove because we assume there are no changes in the temperature, so we can remove that. So we just have P1 V1 is equals to P2 V2. So what will be P2? We need to find P2. Looking back at the load, we can find the pressure. So let's just call P oil of the cylinder. This is equals to the force, the load, divided by the area. So this is pi r squared. If we compute this, we will get 6790 pound per square inch. So this P oil, this pressure will be the same here. You know, by Pascal's law it should be the same, but here we have a different diameter, so the pressure will be the same, but the force here will not be the same. So we can find the force, because we want to push the cylinder equivalent amount to push this load. So let's just use a different color. Let's just call another force F2 here. So F2 is equals to the oil. Remember, the oil pressure will be the same everywhere, times the, so remember that pressure is equals to force divided by area always. So then force is equals to pressure times the area of this oil piston. Then F2 will be equals to 6790 times pi. Now this oil piston has a diameter of 1, so the radius should be 1 divided by 2 pi r squared. So this is F2, 6790 pi 1. Okay, and this F2 is also the same F2 applied throughout the piston, right? So this P2 will just be again the force, which is F2, divided by, since we want to find the pressure required, the pressure that the air should have, so that it can have this amount of force. So we can use this air piston value F2 divided by this air piston. So this should be equals to, so this F2 divided by pi 8/2 squared. So if you substitute the values, then P2 is equals to 106 pound per square inch. Remember, this is gauge value. So that's P2. Now, since we know P2, then we can compute V1. Okay, so if I just, once we know V1, we can compute Q1, which is what it's required. V1 is equals to P2 V2 over P1. So this is equals to V2, the volume of air displaced is, we found it before, which is 101, times P2 and P1. So P2 is 106, but remember this is gauge pressure. we are using this is gas law, so we should use the absolute value for pressure and temperature. So to change from gauge to absolute values, we just add the atmospheric pressure. Okay, so V2 P2 P1 is just 14.7. Okay, so this is 101 times 106 plus 14.7 divided by 14.7. If you do this, you will get 829. Right, 829 cubic inch. If you just want the flow rate, just divide by time, so you would have Q1 P1 is equals to Q2 P2. So if you divide it by time, then instead of having V1, then it's just Q1. So but the time that we want is just 1 second, so then that means Q1 is also equals to 829 cubic inch per second. But remember, we want to find in standard cubic feet per minute, so you just change this, just need to change this to feet and this to minute. Okay, so you can do the conversion on your own. You will get 28.8 cubic feet per minute of SCFM. Okay, so that's the more lengthy part of the question, which requires you to use a little bit of Pascal's law, a little bit of knowledge on ideal gas law, and also the definition of pressure and force and so on. Okay, I hope this helps you to understand the concept of hydraulic and pneumatic system. So that's it. I hope you understand. Please ask question in using the comment section or either our WhatsApp group. So thank you everyone. I hope you stay safe at home. I hope you are all in good health. See you next time. Assalamualaikum warahmatullahi wabarakatuh.